Station 1 is a station where you're going to explore how important it is to wash your hands before you handle food. In these cups I have hand lotion, and in the hand lotion I put a little bit of UV powder that's going to glow under UV. There's probably bacteria in here also, but we're not going to be looking at bacteria. So what you're going to do at Station 1 is take a little tiny bit of lotion and put it on your hands, just like you would apply hand lotion. And then you're going to use the UV flashlight to see if there's any bacteria. Oh, look at it all. Look at that. And where is it? It's on my hands, it's around my jewelry, it's around my nails, it's everywhere. Then you're going to wash your hands. I'll just use a baby wipe. You're going to wash your hands to see how much bacteria washing your hands gets rid of. And let's see. Let's use the light again. Did I get rid of it all? I don't think so. Look, it's still all around the same places. It's still there. It really didn't do much to get, I have stuff. It really didn't do anything to get rid of it. And I'm even leaving fingerprints on the table. So hand washing really doesn't get rid of your bacteria as much as you should. Station 2 is looking at pH. Look over here. Station 2 is looking at pH. pH is how much acidity is in your food. Bacteria grows best when food is a neutral pH, when food has a pH of something like 6 to 7. So what we're going to use is red cabbage juice, and red cabbage juice is an indicator. It's called an indicator because it indicates pH. If you put red cabbage juice into a food that has a neutral pH or a pH of 6 to 7, it'll be blue. If it has a pH of 4 to 5, it'll be, is that green? No, that's purple, sorry, purple. If you go to the pH 2-3, it'll be pink. If you put it in food that's a pH of 8 to 9, it'll be green. And if you put it in a pH that's 10 to 11, it'll be yellow. So we're going to put a little bit of cabbage juice into each of these test tubes. And then we're going to add some food substances to see what pH those food substances have. The food that has the pH that's closest to blue, which is 6 to 7, is the food that bacteria grows the most readily in. And food that has pH much higher than 6 to 7 or much lower than 6 to 7 is food that bacteria doesn't grow in. So this test tube says B, so I'm going to put a little bit of baking soda in there. And let's see what color it changes. With the baking soda, it's not pink, it's not purple. Yeah, it's green. So bacteria is not likely to grow in this. It's pretty green, bacteria is not going to grow. So baking soda can sometimes be used to preserve food. This says L, so we're going to add some lemon juice. And you can see that's definitely pink. Bacteria is not going to grow in lemon juice. Lemon juice is usually a pretty safe food. There's not much bacteria in it. This is a control. Control is the test tube that you don't do anything to. You just look to see what it would be like if nothing happened to it. So it's kind of in between the purple and the blue. This test tube is for milk. And you can see milk is kind of in between the blue and the purple. That's a danger zone. In between blue and purple is the place where bacteria likes to grow. So bacteria grows in milk very quickly. And the final test tube is V for vinegar. When you add vinegar, look at that. It's nowhere near blue. When you add vinegar to food, it's really safe. It doesn't get a lot of bacteria in it. So at this station, we're just looking to see how different foods have different acidities, and the ones that are closest to neutral are the ones that are the most dangerous. This control was the one that had nothing added to it, and the milk really didn't change the pH, so bacteria grows in milk really quickly. Station 3 looks at temperature. At Station 3, we have 3 different temperatures of water. We have hot water, which is about the temperature